sketch B that is a cylinder that's extruded. Or we can have a representation where we have a sketch A that's extruded, a sketch B that has a hole in it that's extruded, and the two are united together. And so this issue of, do we have a complete solid? Yes, we do. Is it unambiguous? Well, we look at it and think that it's unambiguous, but we can also kind of attach to that the notion of uniqueness. Is it a unique solid? So if it's unambiguous, is it a unique solid? No, there's 2 different ways, 4 different ways. There's many different ways of creating this. The book talks about a number of different representations that we can use for doing solid modelings, different schemes. The first one that they talk about is half spaces. Okay? We'll see what that actually is in just a minute. The second one is BREP. The third one is CSG, constructive solid geometry. And the last one that the book talks about are sweeps, which are basically a sketch that's taken in a normal direction. So what's a half space? Okay. Well, one way to think of a half space is just you have a plane and ask the question, on which side of the plane am I on? The side that I'm on is solid. The side that I'm not on is empty, open, okay? So we could say, you know, everything to the right of that wall, to the left of this wall, behind this wall, in front of that wall is solid. In other words, the room we're sitting in is solid. Everything outside of that is hollow. And that technique of half space definition was exactly how they created the first solid modeling systems. When all they had were surfaces to work with, back in my day, sitting in chairs like you're sitting in, we had surface modeling systems. If you connected all of the surfaces together, you sewed them together, and their outward normals, or their normals, were pointing outward or inward. They all had to have either inward or outward pointing normals. You could say, what is the volume of that space? And it could come back and tell you, even though it was just surfaces, it could tell you the volume. It could tell you the weight if you provided the density. And so the early solid modeling systems were based on half space definitions. So using a cylinder as a half space, all you have to do is say R, whatever your radius is greater than 0, and that represents the half space. Is it an infinite half space? It is. You're not specifying the length of this cylinder. If we wanted to, we could specify other equations that cap the end of it, and that would all of a sudden begin to restrict the half space. But we're either inside the cylinder or we're outside of the cylinder based on a very simple equation. The same with the sphere, the same with cones, the same with the torus. So it's really easy to take known mathematical equations and represent them as a half space. You're either inside the cylinder, inside the sphere, inside the torus, or you're not. Okay? In the section on BREP modeling, the BREP modeler, or modeling, the whole discussion is based around the mathematics that we've talked about the last couple of times. The surface mathematics that we have generated. Early BREP modelers did it as a faceted approach. They would represent the complex cubic surface or bicubic surface by a bunch of planar approximations. And so early on, the BREP modeling technique was viewed as inaccurate because it was a faceted approach or approximation to the actual mathematical surface. Today, BREP modelers are very exact. They still kind of display things as a faceted model. Have you ever kind of zoomed in on an area and then watched the screen update the kind of rough approximation of the surface? That's because it's doing a faceted display. It's faster to do that. And when you zoom in, it'll correct and make it look smooth again. Okay. So this is just a couple of examples of a cone and a sphere that is a BREP representation, but it's driven back to the mathematics that we've been talking about. The CSG approach to solid modeling, the constructive solid geometry, is based on primitives. So one of the primitives that they would base their system on is a block. Okay. Another one would be a simple cone or a cylinder. These were all the primitives, and if you were here early on in solid modeling systems, you would open up the system and you would find that you could create a block, you could create a cylinder, and you could use the cylinder to subtract or remove part of the block. Okay? But you didn't have surfaces. You just had these simple primitives that you used to add and subtract to create the actual object. And the last section, type of solid modeling system is the sweep. And the sweep solid modeling system is basically based on a sketch that gets extruded, revolved, swept along some path. Similar to the images that are on there. Now you'll notice this very last one. You can take a surface and sweep it in a direction, but if you sweep it in a direction, it could end up giving you a non-manifold solid, which is this very thin left edge. And something like that will generally throw it in there, saying non-manifold geometry. Okay? And non-manifold geometries is where you have surfaces that become a singularity or become so thin that they can't be represented by having any material or any volume inside of them. Okay? So the question is, what type of solid representation scheme does NX use? Does it use sweeps? Yeah, definitely uses sweeps. Does it use primitives? CSG? Yep, primitives are there. Does it use BREP? Can you build a kind of free-form surface and another free-form surface and another free-form surface and stitch them all together and say, make me a solid? Yep, it does that. Does it do half spaces? Does it do half space? It doesn't. Okay, not to my knowledge. I've never seen it define a plane and everything to the left of the plane is solid and everything to the right is open. I haven't seen that. I don't think it's possible. So if it does those three, not the fourth one, if it does those three, what kind of solid modeling system is it? The book kind of talks about it's either this or it's this or it's this. In reality, it's a hybrid. My recollection is that the early days of Mikado, now called NX, but when it was built and used inside of McDonnell Douglas as their CAD package, because they built it before they spun it off. My recollection is that it was a surface modeling, a BREP modeling type system. Okay? They were able to stitch things together, and then all of a sudden research in the CSG area started, and the developer said, well, we can add a block, and we can add a cylinder, and we can add a cone, and we can add these primitives, and they started adding those. And then who came up with this great notion of kind of sweep geometry? What was the first CAD system that kind of came up with the notion of sketches and sweep them and revolve them and things like that? It was PTC, Parametric Technology in Pro-E. They developed this scheme of really doing parametric sweeps. And then all of the CAD systems said, well, we can add that feature too. And so what is NX? NX is very much a hybrid solid modeling. What about CATIA, Pro-E, and things like that? CATIA, can you do sweeps?
Yeah.
Absolutely. Can you do primitives? Do they have primitive functions? And they do. There you can insert a block, you can insert a cylinder, you can insert primitive features. Can you build surfaces and stitch them together and turn them into a solid? Absolutely. So CATIA is a primitive, is a hybrid modeler. What about Pro-E? Well, Pro-E was new. It didn't have the legacy that CATIA and NX have had, dating back to the 70s. Okay? So Pro-E kind of was this new, brand new parametric modeling schema that none of the other CAD systems had, and they came out strictly as a sweep. You could revolve, you could extrude, you could revolve, you could go along a path, but that was all you could do. Do they now have surface modeling capability built into Pro-E? Do we have any Pro-E modelers in here? Ones that kind of used to do it a little bit? Okay, they do have surface modeling. About 8 years ago, okay, they were being beat up by not having kind of this surface modeling capability, and they went out and purchased a company called Computer Vision, which was the best surface modeling system in its day. They built that, and they've added all kinds of surface modeling functionality to Pro-E that didn't used to ever exist. Okay? Do they have basic primitives in their system? And they have added those. So they started out as a sweep system. They transformed into a hybrid system. The one thing I didn't mention is if you turn the clock back on CATIA, it started out strictly as a CSG model. So when it brought solids into existence in CATIA, they came in strictly as primitives. They came in as blocks and cylinders and cones, and you can add and subtract them. But they've added all the other functionality since then. So let's talk about kind of the solid representation. So in this glob, this wiggly curve, you have a block that's sitting inside of it, and you want that block to be represented as a solid inside of, it says E3, we typically refer to it as R3. It is the Euclidean space that we're talking about, so it's XYZ space. So we have this block in there, and the block, okay, for it to be represented as a solid, it has to have all of the inside, so the IS is the interior of the solid, plus the BS, which is the boundary of the solid, and those two combined will give you a closed solid. So mathematically, what is this? What is the dashed IS?